We're solving problem 25 from the 2020 F equals MA. Exam A. A ball of negligible radius and mass m is connected to two ideal springs. Each spring has rest length L0. The springs are connected to the ball inside box of height 2LO, and the ball is allowed to come to equilibrium as shown. Under what condition is this equilibrium point stable with respect to small horizontal displacements? And we have all these inequalities. So for this problem, since we're dealing with springs here and all these angles, we want to find out a way to basically make things like true. So first thing we can say is spring constant K1 x plus K2x is equal to mg. That's how much is being pulled down at that point right there. Then we can factor out the x from both these terms to get x equals mg over K1 plus K2. Now for small horizontal perturbations, at this point it has to be such that K1x sine of that angle right there, d theta 1, has to be greater than K2x sine d theta 2. Then, keeping with the leading order at this point, we get that this is K1x times change in x over LO minus x is greater than K2x change in delta x over LO plus x. Now, most of these terms cancel out, and then you're left with K1 times LO plus x is greater than K2 times LO minus x. Now at this point, you can multiply these out and then move these around. So multiply in this case K2 times LO minus K2 and x. So then you can like move this x over here and move this k over there. So then this would be, and then since both of these k's are being multiplied by an L0, factor L0, K1 minus K2 is greater than, factor out the x, and then K1 plus K2. Therefore, this can all just be, since you plug in x is equal to this, that cancels out. So therefore, K1 minus K2, and then divide by the L0 has to be less than mg over LO. This is our answer, and it correlates to answer choice C on the test. So that is the solution for this problem.